Good morning, friends. Today we will see the next chapter, that is a theory of indicator for the syllabus pharmaceutical inorganic chemistry, Form D as well as B Form C. So this is a chapter of theory of indicators. We'll see in that what is meaning of theory of indicator, what are the indicators, what are the requirements of indicators, etc. So first of all, we need to know the meaning of the indicators. Indicator is a substance which changes the color in response to the chemical reaction, especially in a titration. It is added to the derived exact endpoint for the volumetric as well as compleximetric titration. It is a substance. It is a substance to give the end point. After addition of this, it will give the end point of the reaction. It is called as the indicator. First of all, keep in mind there are three types of indicators which is discussed below. Self indicator, basically these are not an indicator, it is one of the reacting species of titration, titrant or titrate, which is after completion of the reaction exchange the color of the solution itself. Self indicator itself, they will change the color, so we can tell that self indicators. The best example is the potassium permanganate. Best example is potassium permanganate is the best example for that, which is a self indicator. After completion of titration, the color of the solution becomes transparent, but when one more drop potassium permanganate we can add, then it will be changes the color to the of the solution to the light pink, indicating that is the end point of the titration. Okay, तो यहाँ पे हमें क्या पता चलता है कि सेल्फ इंडिकेटर मीन्स द पोटेशियम, एग्जांपल पोटेशियम परमैंगनेट है जो कि खुद ही इंडिकेटर का काम करता है. When addition of the potassium permanganate drops in the conical flask, it will give the changes of the color, light pink colors. Okay, so ये यहाँ पे यही मेंशन किया है कि सेल्फ इंडिकेटर्स. ओके, नेक्स्ट है इंटरनल इंडिकेटर्स. In internal indicators, these are those indicators which takes parts in the reactions. Okay, after completion of the titration, it changes the color of the solution, indicating the sharp end point. Okay, यहाँ पे क्या है कि हम जो indicators हम during the reaction हम involve करते हैं, जो कि हम add करते हैं, that is internal indicator, and they will give the end point, sharp end point. Example है diphenylamine, which is used for titration of more salt. Then potassium permanganate. Some more examples is methyl orange is there. Then methyl red is there. Phenolphthalein. These are the common indicators we are using as an internal indicator. Okay. यहाँ पे उनकी ज़रूरत पड़ती है internal indicators की. Next है external indicator. Indicator which never takes part original chemical reaction, but after completion of reaction. Okay, after completion of reaction, it will be the changes the color of the solution, indicates the end point. External indicator is not recommended as it leads to loss of volume the reaction mixture. One of the well-known example is external potassium ferricyanide. Okay, so these are the external. This is the external indicators which is never take part in original chemical reaction, but after completion of the reaction, it will changes the color of the solution. This is called as external indicators. An example is potassium ferricyanide. Next, so we've seen already the types of the indicators. Now we'll go to the theory of indicator. Indicators should be weakly acidic or basic in a nature. Indicators should be okay. Hence weakly acidic रहना चाहिए or weakly basic होना चाहिए. An indicator is a substance which show the characteristics changes in the color when the comes in the contact with the acid or base, and thus it is used to determine the degree of the acidity or basicity of a solution. Okay, contact किसके में आता है, acid or a base, then only it can change the colors, and it is degree of the acidity and basicity of the any solution is important. For example, litmus solution or litmus paper. Then role of indicators in chemistry is very important. They are used also used to find out the end point of the titration. ये तो हमें पता है, simple titration का end point चाहिए तो indicator is very important part. In acid base titration, organic substances, weak acid or weak base are generally used in indicators. Weak acid and weak base in acid base titrations. Indicator changes their color within a certain pH ranges. pH ranges का भी इसमें बहुत सारा part है. We have to, according to the pH ranges, it will be changes the color. First theory है Oswald theory of ionization. According to the Oswald theory, the color changes of any indicator. Color changes of any indicator is due to the ionization procedure. Unionized form of indicator has different color than the ionized form. Ionization procedure important है, ठीक है? It is totally depend on the ionization of the ionization procedure for the Oswald theory concept. And indicators in a is either weak acid or a base. Yeah, then it is only weak acid or a base. So it is ionization is highly affected in acids and bases. If an indicator is a weak acid, its ionization would be very much low. In acid में बहुत low रहता है और base its opposite base में fairly ionized रहेगा, ठीक है? In same way, if indicator is a weak base रहेगा तो क्या रहेगा? Its ionization is large in acid and low in alkali. Same. Okay, vice versa. So let's take example of two important indicators, that is phenolphthalein and which is a weak acid, and methyl orange is a weak base. These are the two with different examples of weak acid indicator and weak base. Weak acid is a phenolphthalein and weak base is a methyl orange. First of all, see the phenolphthalein. See, it is represented as a HPH. This indicator being a weak acid ionized in a solution to a small extent as HPH. See this reaction here. This is the colorless acid like this. This is the colorless acid before the reaction, before the titration. After we'll get the H plus pH minus, that is the pink base. This is the pink base. Applying the law of mass action as it is. The undissociated molecules of, that is the mass action. According to the law of mass action, undissociated molecules of the phenolphthalein are colorless, while the pH ions are the pink in color. In presence of an acid, suppose in presence of an acid, ionization of HPH is practically negligible as equilibrium shift to the left hand side due to the high concentration of H plus ion. Already हमने देखा है कि suppose the reaction is in the acid media, then it will not react, that is not ionization properly. Okay, thus the solution would remains colorless, reaction नहीं होगा, ionization properly नहीं होगा. On the addition of alkali, if suppose हमने addition alkali किया, hydrogen ions are removed after addition of alkali and by OH ions, and it forms a water molecule and equilibration shifted to the right hand side, and thus the concentration of pH ion increases. Thus the concentration of pH ion increases in the solution, and then it will be impact as a pink color to the solution. Okay, according to the theory. Okay, it will be reacts in alkali only. ये simple आपको ध्यान रखना है. Next is methyl orange indicator. It is very weak acid, weak base can be represented as a MEOH. Okay, contains MEOH. It is ionized in a solution, gives the Me plus and OH minus. This is the, see, yellow basic MEOH, and it will give the red acidic. Applying law of mass action, in presence of an acid, OH ions removed in the form of water molecule and above equilibrium shift to right hand side. Thus the sufficient Me ions are produced which impart the red color solution on addition alkali Alkali suppose हमने ऐड की है, ions increases the solution equilibrium shift is to left side and ioniization MEOH is practically negligible. क्योंकि यहाँ पे हमने क्या बोला है, वीक बेस अगर रहेगा इट विल बी नॉट रिएक्टेड प्रॉपरली विद द एसिड, सॉरी, it is reacted with the acid but it is not reacted with the base. Thus the solution acquires the color of the unionized methyl orange molecules to the yellow color. See, only दो concept आपको ध्यान रखना है. If suppose we have indicators as a weak acid, okay, so it will be better ionized with the base, and suppose weak base है, it is better ionized with the weak acid. Okay. This theory also explains the reason why the phenolphthalein is not a suitable indicator for the titrating weak base against the strong acid. The OH ions furnished by the weak base are not sufficient to the shift the equilibrium toward the right hand side considerably. pH is not reached 8.3, thus the solution does not attain the pink color. Due to this reason, the phenolphthalein is not suitable. Okay, at an indicator in a weak base. Similarly, it can be explained by why the methyl orange is not suitable indicator in a weak acid. Say, vice versa. Hmm? Next theory is quinonide theory. According to this theory, an acid indicator exists in two tautomeric forms. See, there are two forms is there, benzonoid and quinonides. Different structures which are in equilibrium. One form is termed as a benzonoid and second form is a quinonide. This is the benzonoid form. See, this is the benzonoid form. 6 carbon atoms is there. Quinonide form, 6 carbon atoms there. Only the okay. So only the difference is the different forms are there. The two forms have different colors. Color changes is due to the interconversion of one tautomeric forms into the other. One form mainly exists in acidic media and other in alkali media. Thus, ये एक acidic media में exist रहता है, एक alkali media में. Thus, the during titration the medium changes from the acidic to the alkaline or vice versa. The changes in pH converts from one tautomeric forms into the other. Thus, the color changes occurs. Okay, simple quinonide theory. यहाँ पे दो different forms रहेंगे tautomeric form, that is benzonoid and quinonides. According to that, they will change the different colors due to their interconversion of the one tautomeric forms to other emitters. Okay. Phenolphthalein has a benzoid form in acidic media and thus it is colorless. While it is quinonide form in alkali media, it will give the pink color. Okay, see, this is the just simple reaction here is given as a pink color. When methyl orange has quinonide forms in acidic media, then benzoid forms in alkali solution. The color of the benzoid form is yellow, while the quinonide form is red. These are the simplest examples and reactions are given here as a quinonide forms and benzonoid forms, and it will give the changes colors when it will be reacts with the acid media or alkali media. It will be shown in a reaction as well. So just we have to understand only the two theories, that is the first of all the Oswald theory and quinonides theory. So okay, so what was in this chapter? First of all, we'll see saw the what is the exactly meaning of the indicators. Then what are the different types of the titrations? There are three types of titrations. Indicators: self indicator, and internal indicator, and external indicator. Then theory of indicators. What is the exactly basic of the theory of indicator? That is the ionization procedure. Okay. Then indicators must be as weak acid and weak base. Then first theory is Oswald theory of ionization. It is totally depend on the ionization procedure. Okay. Next theory, there are two examples of Oswald theory, that is phenolphthalein indicator and methyl orange indicator. Next is the quinonide theory, that is totally tautomeric forms, that is benzonoid and quinonide forms. Okay, so this is the chapter ends. Okay, Just watch full video for understanding purpose. If you have any questions, please come put questions in the comment box. As well as those are not for subscribe this channel, please subscribe this for more video. Thank you very much. Thank you.